Hello everyone, my name is Sajid and today we will be going to discuss problem number 142, linked list cycle second. So let us read the problem statement now. So we are given the head of a linked list and we have to return the node where the cycle begins if there is a cycle, and if there is not, then we have to return null. So now there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So it means if we are traversing the linked list and if we reach a pointer which occurs twice, then we can say that the linked list contains a cycle. Alright. So now it states that we do not have to modify the linked list, and let's see a test case. The test case states that we have a first node as 3, then for the next pointer we reach 2, then we reach 0, and then we reach -4, and then we again reach 2. Since it has a cycle, so now we go to the second part of the question, which states that we have to return the head of the cycle, the starting point of the cycle. And clearly in this case, we can see that the starting point of the cycle is 2, which is at index 1. Alright. Okay. And now it has a follow-up aspect. It states that can you solve it in O1, constant memory. So let's now first discuss the ON memory solution. In that solution, you can simply take an unordered set, or an unordered map, anything, and as a key, you can take the address of the pointer, all right? And as a value, you can take as how many times has it till now discovered, all right? So let's say that you are traversing this follow-up, only, and then first you reach 3, then you reach 2, then you reach 0, then you reach -4, and when you reach the 2 again, you see that 2 has already been visited, so you say that okay, this contains a cycle and we can print 2. So that will be the very simple solution in ON. But let's say if we want to make a solution in O1 space complexity, then to do that, let us see the solution. So the step 1 will be find a loop, and that we will be doing using a slow and a fast pointer. Now the slow pointer will be moving to next node while fast pointer will be moving 2 times faster. Alright. So basically slow will be changing as slow next, and fast will be changing as next of fast and again and next. Alright. And now you will ask that okay, so why does this will meet at a point where we are saying that they will meet only if there is a cycle. What is the guarantee that they will be meeting if there is a cycle? So to explain this, just think about it like this. You have two pointers, a slow and a fast, all right? And then the slow pointer is moving slower than the fast pointer by a margin of 2 times. Okay, so from the slow pointer perspective, let's say he is standing still, then the fast pointer must be going one step at a time, because the slow pointer is moving one step, the fast is moving 2 steps. So from the slow pointer perspective, the fast is moving only one step ahead of him every time, all right? So now from common sense only, we can tell that if the fast pointer is moving one step at a time and there exists a cycle, then the slow and fast are bound to meet, okay? So that's what we are doing here. If they meet, we break the loop and we check if the loop was broken due to this condition or because of the linked list has ended. If the linked list was ended, then we say that there's no cycle and we return null. Otherwise, we know that there's a cycle exists. Okay. Now for the step 2, let me show you a diagram. Now let us say that the A point, this point represents the head of the linked list. The B point represents the point where the cycle starts, which we have to find in this case. And the C point represents the point where the slow and fast pointer met in the cycle. Okay. And now these points, I've just taken 3 points here, but they can be, many points in between A and B, B and C. Okay. Because the 3 points are of our concern. Now we know that speed of fast pointer is twice the speed of slow pointer. We assume this in the beginning, right? So now from this analogy, since the time is constant, we can say that the distance of the fast pointer, the distance the fast pointer traveled will be twice the distance of the slow pointer, right? So now from that statement, we can, distance of fast pointer will be the distance from A to B, X, plus it might have, taken certain number of rounds in the cycle before it met, all right? So that will be C1, the number of rounds, into N. N is the length of the cycle, plus when it reaches the starting point again, it travels the distance y to meet the slow pointer, right? Similarly, for the slow pointer, it will be x plus c2, the number of loops the slow pointer takes, plus y. And it's 2 times, right? So we write an extra 2 here. Solving this gives us x plus y is equal to c1 minus 2c2 times n. And now c1 minus 2c2 can be written as some other constant, right? Maybe c or d. So I have wrote it like this. And then we obtain the relation x plus y is equal to cn. Okay. And now from this relation, what I have said is that the point where PTR, which is the head, and the slow and fast pointer meet will be the starting point of the loop. Now, why I'm saying that is, let us assume that a new pointer PTR which points to the head of the linked list, and we are taking a slow pointer which is at the position C, right? Now we are saying that when the head reaches the cycle starting point, it has to travel x nodes, all right, x distance. And when the C pointer, it travels x distance, it will reach the B point only, because from this relation we know that the C is at a distance of y initially, and if it travels x more, then from B the distance of C will be x plus y, and since x plus y is a multiple of the length of loop, so it will eventually end it up at B. So we can say that the PTR and the slow pointer, if they are traveling a distance x, they will end up meeting at the cycle starting points which we need to find. All right, so doing that here only, so we are running a loop till they don't meet, all right, and they meet at the point. And so now we can return any of the answer, because the answer is PTR as well as slow as well. After the loop, they are pointing to the same cycle starting point, so we return that, and that's how we solve the question. So let me now submit and check if that's correct. And all right, we have solved the question, and thank you. That's it from my side.